Hello again, everyone. Today we're going to discuss about titration. Um, titration, and we first have to define what is the meaning of titration, and then later on we will do some practical example. Titration, I'll try to give you the definition. Maybe the easiest definition of titration is the process of finding the concentration of unknown solution by using a standard solution. So that's what titration means. I mean, in different literatures there is a different definition, but the basic concept of titration is by using the standard solution, you're going to determine the concentration of the unknown solution. So we have two cases here. We have known solution and unknown solution. The standard solution is basically the known solution. Let me give you an example. Say, for example, you have a 0.1 molarity of sodium hydroxide, and by using the 0.1 molarity of sodium hydroxide, you may be asked to determine the unknown molarity of hydrochloric acid, which is an acid, and this is a base. So first we can write the reaction between acid and base, which is sodium hydroxide with hydrochloric acid. That gives you sodium chloride plus water. By the way, a reaction like this nature is called a neutralization reaction. The reason why we say neutralization reaction is that because the products that are formed are salt, which is pretty much neutral, and water. It's neither acid or a base. So how do we do titration here? So let's say we have sodium hydroxide is going to be our standard solution, which is 0.1 molar, and the hydrochloric acid is unknown solution, concentration is unknown. I'm going to put X, and by using sodium hydroxide, our standard solution will be determined the concentration of hydrochloric acid. That's what titration is about. So we have hydrochloric acid, which is aqueous, react with sodium hydroxide, which is also aqueous, gives us sodium chloride, aqueous, and water is a liquid. So we don't know the concentration of hydrochloric acid. I would say Xm, where M stands for molarity. We know the concentration of sodium hydroxide, which is 0.1 m. This is called our standard solution. So let's assume that we have 20 milliliter of HCl, and by using this amount we're going to determine the concentration of hydrochloric acid. So one of the basic concepts here is that for us we need to determine what is equivalence point. Equivalence point, it is a point at which the number of moles of an acid, which is the number of moles of hydrochloric acid in this case, equals to the number of mole of sodium hydroxide. So you can say number of moles of an acid, I'm going to use an abbreviation, Na, equals to Nb. When you get to this point, we call this point equivalence point. Now the question is, how do we know that we reach to equivalence point? When you do titration in most cases we use indicators, and the indicators will tell you that whether you reach the equivalence point or not. So the common indicator that we use for titration is called phenolphthalein. Of course, there are so many indicators, but in this case we're going to use phenolphthalein. Phenolphthalein is colorless in acidic media. If you put a drop of phenolphthalein in acidic solution, you don't see any color. In a basic media, it provides you a pink color, pink in basic media. So if you have a dark pink color, you have more alkaline solution. If you have a colorless solution when you do a titration, that is going to be acidic solution. So what we are looking here is a very light pink color. Remember, very light. Sometimes it's called faint pink color. Faint pink color. If you see a faint pink color, it means the number of moles of an acid equals to the number of moles of a base. So if the number of moles of an acid equals to the number of moles of a base, which means that molarity of the acid times volume of the acid equals to molarity of the base times volume of the base. So what happened is, as you know, molarity is number of moles over volume of solution, so N equals to M times V. Now when I say MA, MA refers to the molarity of the acid, VA refers to volume of the acid, MB refers to molarity of the base, and VB refers to volume of the base. So we basically have a burette. Remember, a burette looks like this, and a burette has its own something called stopcock, and a burette is also calibrated. There are numbers. Most burette starts from 0 up to 50 milliliter, and here you have a flask, mostly like a flask of 25 milliliter or 50 milliliter. Over here we're going to add the titrant solution, which is in our case is hydrochloric acid. And remember that to ionize the solution we may use about the same amount of distilled water. Let's say if you have 20 milliliter of hydrochloric acid, we can also add 20 milliliter of distilled water. And we also have we need to add indicators here. The amount of indicators in most cases would be 2 to 4 drops would be enough. Over here on the burette, it's called a burette, we have to add our standard solution. Our standard solution is sodium hydroxide, which is a 0.1 molarity of sodium hydroxide will be added here. So when we start a titration, make sure that every drops that goes here, in each drops, make sure that you have to swirl the flask so that reaction will take place here. At some point, this color has to be changed into a light pink color. Sometimes it's called a faint pink color. As soon as you see a faint pink color, you have to turn off the stopcock here. This is called a stopcock. You have to turn off that. You need to stop the reaction, and then you're going to read the volume here, the volume of the base, which is your standard solution, maybe 19 milliliter. I just put a hypothetical number, 19 milliliter. At the point when it reaches into 19 milliliter, you see a light pink color, that's going to be the volume of the base. That's going to be the volume of the base. Now, so our goal is to calculate the molarity of the acid. So from the relations that we have, molarity of the acid equals to molarity of the base times volume of the base over volume of the acid. So we have the molarity of the base, which is our standard solution, which is going to be 0.1 molarity. Volume of the base, it is going to be the base that the volumes that you see the faint pink color. We pick a number here, 19 milliliter, divided by the volume of the acid that's already given here is 20 milliliter. So 0.1 times 19, by the way, milliliter and milliliter will be cancelled out, so we don't need to change into liter. 0.1 times 19, that basically gives you 1.9. 1.9 divided by 20, that would give you about 0.09 m. So this is basically the concentration of hydrochloric acid. So to summarize this, you had the standard solution, which is 0.1 molarity of sodium hydroxide. You use the standard solution of sodium hydroxide to determine the unknown solution of hydrochloric acid. So after the process that we did here, we came up with 0.09 molarity. So titration is basically finding the concentration of the unknown solution, in our case is hydrochloric acid, by using a standard solution, which is, in our case, is sodium hydroxide is our standard solution. This is the whole point of titration. If you have any questions regarding this titration, I'll be happy to explain more, and don't forget to provide us your comments on the video, and any suggestions also will be appreciated. I'm going to discuss on the next video a different topic, maybe like thermochemistry. So until now, goodbye, and I'm looking forward to hear your comments regarding this video. This video is basically about titration. Have a nice one, everybody.